So, what if I told you that everything we know, I mean everything, every star, every planet, you, me, is just a tiny, tiny fraction of what's actually out there? Yeah. There's a huge cosmic ghost story playing out right at the heart of physics, and it pits a universe full of invisible stuff against a wild rebel theory that dares to question the laws of Einstein himself. Let's dive into this massive cosmic mystery.
Just look at this. Seriously, take it in. That tiny little 5% slice, that's all of it. That's all the matter and energy we can actually see and understand. The rest of it, that massive 95% chunk, is a complete and total mystery. It's this vast, dark enigma that science has a name for: dark matter.
Okay, so you're probably wondering, how in the world did we figure out we were missing 95% of the entire universe? Well, it all kicked off with a really simple observation, something that I kind of like to call the galaxy's madness.
So here's what happened. Physicists did the math. First, they added up all the gravity from all the stars and gas and dust they could see in a galaxy. Simple enough. Second, based on that number, they predicted that the stars way out on the edges should be moving pretty slowly. Any faster and gravity would lose its grip and they'd just get flung off into deep space. But then came the third step, the observation. When they actually looked through their telescopes, they saw those outer stars were spinning impossibly fast, completely defying the laws of gravity. Something else, something invisible, had to be out there, holding it all together.
And just like that, science gave this invisible something a name: dark matter. The idea is that it's a hypothetical, ghost-like particle that doesn't interact with light at all, but it has mass. It's essentially the universe's invisible cosmic glue, providing all that extra gravity needed to stop galaxies from literally flying apart.
So, we have our prime suspect. It's invisible, it's pretty much everywhere, and it's holding our universe together. But who, or what, is this suspect really? Let's zoom in on the leading theory.
The scientific community's best guess, the mainstream idea, is that dark matter is made of something called a WIMP. It stands for Weakly Interacting Massive Particle. And it's exactly what it sounds like. Imagine a particle that's incredibly heavy, but it's so ghostly that it could pass right through you, me, and this entire planet without ever hitting a single thing. I mean, it's the perfect cosmic fugitive, right? Okay, so we've got a suspect, we've got a profile, the hunt began. But this is where our little cosmic detective story takes a really strange and frankly frustrating turn.
For 4 decades, we've been hunting for these WIMPs. The search started way back in the 80s. In the 2000s, we built these gigantic, super-sensitive detectors deep underground in mines to shield them from any cosmic ray interference. By the 2010s, even the Large Hadron Collider got in on the action, trying to smash particles together to create a WIMP in a lab. And the result? Every single time, nothing. No detection. Zilch.
And listen, this wasn't some small effort. We're talking about a massive global hunt that has cost billions of dollars, involving some of the absolute brightest minds on the planet. And yet, after 40 years and a mountain of cash, there's absolutely nothing to show for it. So you have to start wondering, what if we're chasing the wrong ghost?
This constant nagging failure, it cracked the door open for something else, something radical, a rebellious idea from a lone physicist. A theory so bold it doesn't just question the suspect, it questions the very laws of physics we hold so dear.
Way back in 1983, this Israeli physicist named Mordechai Milgram looked at this whole cosmic mystery and proposed something truly revolutionary. He basically said, hey, what if there is no missing matter? What if our understanding of gravity is just wrong?
So here's the showdown, right? It's pretty simple. The dark matter theory says, nope, Newton's laws are perfect, but the universe is filled with tons of new invisible particles. Milgram's theory, which is called MOND, says no, there are no new particles. Instead, it suggests that Newton's law of gravity itself actually changes. It gets a little bit stronger in places where the gravitational pull is incredibly weak, like on the far, empty edges of a galaxy.
And here's the really shocking part. MOND works. It works frighteningly well. Without needing any dark matter at all, its simple mathematical formula perfectly predicts the exact rotation speeds of hundreds and hundreds of different galaxies. It solves the whole problem with just a little tweak to the math, not by inventing a bunch of new cosmic stuff.
But in science, a theory is only as good as its toughest test. And deep in space, nature itself provided the perfect arena for a final, epic showdown between these two cosmic heavyweights.
This is the bullet cluster,
I mean, the name alone sounds intense, right? What you're seeing is the aftermath of a spectacular high-speed collision between two entire clusters of galaxies. It's the perfect natural laboratory to see how gravity and matter behave under the most extreme conditions you can possibly imagine.
All right, let's look at the results from this cosmic crash. The dark matter theory predicted that the normal stuff, the gas and dust, would smash into each other and slow down, but the ghostly dark matter would just pass right through no problem. So gravity's center of mass would actually separate from the visible matter. And guess what? That is exactly what astronomers observed. A huge win for dark matter theory. MOND, on the other hand, predicted that gravity should have stuck with all the visible matter. So this observation is a massive problem for MOND, though its supporters are working on ways the theory could be modified to explain it.
So where does that leave us? Well, it's kind of messy. We've got one theory that totally nails this incredible cosmic collision test, but has failed every single direct search for 40 years. And then we have this other theory that perfectly predicts how galaxies spin, but it stumbles at the scene of a cosmic crash. The case is far, far from closed.
This really leaves us at a fundamental crossroads, and the answer is going to redefine the future of physics, because this debate strikes at the very core of how we think the universe actually works. So will we finally find that elusive ghost particle, confirming our current model, or will we be forced to admit that our most basic laws of nature are incomplete and add a brand new chapter to the rulebook written by Newton and Einstein?
And that brings me to the final question, the one I want to leave with you. After seeing all the evidence from both sides of this incredible cosmic debate, what does your gut tell you? I mean, really, do you believe in ghost particles, or is it time to change the law?